So our original y was, our original range was that y had to be greater than or equal to 0. Because our starting point is 0 here, we have a range that is going to get two things that we need to worry about is the sign in front of the y and the shift. Reason being, when we have a 0 in here, the number of the 2 doesn't actually matter because 2 times 0 is still going to be 0, right? What we are worried about is the direction of the greater than and less than symbol. Okay, if I started with y has to be greater than or equal to 0, but then I flip everything upside down, the upside down piece affects the direction. Now it's less than or equal to 0, right? The other piece that affects it is the +1. The +1 is going to now take everything that's negative and bring it up by 1 value. So I'm going to add 1 here. And so my range is going to be less than or equal to 1, which matches our picture up top. Okay, so because our starting point was 0, the value of the stretch doesn't matter in this case. We are only worried about, do we have to flip the sign and do we move it up or down in terms of a shift? Okay. Any questions on that? All right, let's go on to this example. In this example, I'm going to cross out all this bit here. I want you to do this example on your own. Fill in the chart. I want you to show me the mapping notation. Okay, and I want you to remap these 4 points, but one of them is already done for you. So tell me what these coordinates are with this new transformation. And also, can you tell me domain and range? So take a moment. Don't look at your screen. Work together. Write it out. I think it is in our SD folder. So if you've done the first part, you can check your work. Oh, anybody catch a mistake there? Okay, so essentially the first 4 key points, what are they getting mapped to? So this time around, I want the ugly coordinates because we're not going to draw it. I just want the coordinates. So you're putting all of your x values through this equation and all of your y values through this equation. So when we have some of the uglier coordinates, you can leave it as a fraction. It's usually easier to leave it as a fraction in lowest terms, but you can also write it as a decimal. Either way is all right with me. So 4 over 2 is -2 minus 5. 2 times 4 is 8 minus 5 is 3. All right. -9 over 2 minus 3. Oh dear. -9 over 2 minus 6 over 2. -15 over 2 and 3. Times 4 is 12. Okay, can you double check what you got as what I got? Match up? Okay, talk about domain and range. Here is the transformed equation. Think of how we did domain and range in the last page. Can you identify, first let's do range, because range we can kind of do through observation. I do not have a negative out front, so it's not upside down, so my sign stays the same. I have a shift down, so what's my range? Bigger than -5. Right? Because in my original, y has to be greater than or equal to 0. Because I didn't flip it upside down, the sign stays the same, and I just worry about the last number. Okay, so we know the range. Somebody do the calculation for domain. X is greater than or less than? It's going to be less than. Why less than? Why less than? What do I see inside the bracket? There's a negative, right? So your negatives are going to change the direction of your greater than, less than, your inequality symbols. So it's going to be less than, and what's the number? Where's your origin? It's going to be less than or equal to -3. Okay, so we reflecting it over the y changes the inequality. The value is based on the shift. Okay, last page. In this section, I give you a picture. I want you to fill in the blanks of the A, B, H, K. Now, we did this a couple of times in the last unit. In fact, you wrote a quiz on it. Here's the difference between this question and the question you did 2 or 3 times before. In the last question, in the last unit, I gave you the original points, okay? And I told you where they mapped to. I would say, for example, 0, 0 is now being mapped to 4, 2. And then I would give you a second point. For example, 9, 3 is being mapped to 8, 8. because then you could measure the height and the width of your functions and figure out if there has been an expansion. In this case, I am not telling you what the points are tracking to. So you have to guess by inspection, is this a vertical stretch or is it a horizontal compression? There's two ways you can do this, two right answers. Depends on how you go about sorting it out. So I'm going to pause the video here and I want you to spend at least 8 minutes trying to sort out what is the expansion. Is it horizontal and vertical? Pick one. Tell me what the number is. Okay.